So this is where we were last time, that if V and W are vector spaces and you have a linear map between vector spaces, then we can define a map F upper star from LKW to LKV. Remember, F is from V to W and F upper star goes in the reverse order in some sense. By, you take an element in LKW, it is T. That means T is a K multilinear map on W. And I define F star T to be a K multilinear map on V by, what does it do to K vectors in V? It takes T of FV1, FVK. Where are FV1? It's in W. T of these K elements in W makes sense, so this whole thing makes sense. So the first exercise you must verify is that F star T is in LKV. So we have this map which I call upper star. The map upper star is going to go from functions from V to W to a function from LKW to LKV. Okay. Now, obviously, you must have this operation that we have must satisfy the natural things that it should satisfy. Namely, what have we defined on LKV or LKW? We have defined addition, scalar multiplication, that is a vector space structure on LKW. And we have defined one more thing, namely the tensor product. So we have to first of all verify that F upper star is a linear map. This is a statement that F upper star is a linear map. So it respects the vector space structure. But we had one more operation on LKW, namely we have this operation of tensor products. So what you must also verify is that F upper star respects tensor products. What do I mean by that? What I mean is that F upper star of T1 tensor T2 this is that F upper star and this is something you're going to come across more and more often. If you define some operation on a set which already has some structure, here LKW has a vector space structure. So we are defining something on a set which has a vector space structure. And if you want to see that that is well defined, you must say that the new thing that you're defining behaves well with the structure that you have already in place. So LKW has a vector space structure. F upper star should behave well with respect to the vector space structure. Also, LKW has a tensor product structure. And if the thing that you're defining is correct, F upper star should also respect the tensor product structure. And what is the meaning of the respecting tensor product structure? It's the obvious thing which looks like this. Okay? Where what is T1? T1 is in LKW and T2 is in some LDW. Okay? T1 tensor T2 is in LK plus D of W. So F upper star respects tensor products. The next thing we have to worry about is what happens when you have a composition of functions. So we have F and G, V and W and U are vector spaces, then obviously I can construct G composed with F, which is from V to U. So now I have a linear map G composed with F from V to U. My question is, how does star behave with respect to this? So the exercise is, what is the exercise? G composed with F star is actually equal to F star composed with G star. The order of these functions is reversed. Okay? Fancy name of saying this is something to do with contravariance, whatever that means. Okay? But we are not worried about these words right now. It's an exercise to show that when you have composition of two linear maps and you take the upper star of that, the order of these two things are reversed. Let's just confirm that this whole thing makes sense. G composed with F is from V to U. So its upper star should go from where? LKU to LKV. Where does G star will go? It will go from LKU to LKW. And F upper star will go from LKW to LKV. So this composition makes sense. Okay? So this is something that is quite interesting, and it's the first example where you will be seeing of this order being reversed. Okay? But what I want to convince you is that this is something that you have actually seen before. So, what is it that we are going to be doing here? So I think we'll stop. So what we have is the following. And okay, F star is from LKW to LKV. So if I want to write it in this way, I should write LKW, LK. If I want to write it with a V first and a W here, then the arrow that I will be drawing is in the reverse direction. So in this sense, this upper star business reverses the arrows. Okay? And what is happening when you have three functions? You have three functions like this. We have these three spaces, LKV, LKW, and LKU. The composition from here to here is G composed with F. That is a composition there. When you're taking F upper star, the arrows get reversed. So I have F upper star and G upper star. But remember, the arrows are reversed. And the composition is this. First you're taking G star and then you're taking F star. So what I have is that G composed with F, its upper star is F star composed with G star. G star goes from LKU to LKW and F upper star goes from LKW to LKV. This is a bit confusing, okay, that the order is being reversed. And why is it being reversed? So you have to sit down and do this calculation and see that the order is actually reversed. Okay. Now this is actually something which is quite important. And not just that, you have seen this kind of thing earlier. So where have you seen this kind of thing earlier? So now suppose I'm in a general topological space. So X and Y, suppose they are metric spaces. Okay, so these metric spaces play the role that V and W play there. Okay, and F is a map from X to Y. Because you're talking about metric spaces, this function F that you must have must be a continuous function. It's continuous. Now, I want to define this map F upper star in this setup. Okay? I'm purposely keeping the notation the same, so you will see the exact analogy between what I'm doing here and what I had done there. Okay? So F upper star I want to define from continuous functions on X, continuous functions on Y to continuous functions on X. Exactly the analogy that I have there. How will I define this? So take a function which is a continuous function on Y. So let that is T is a map from Y to R. This R doesn't really matter, but let it be R right now. And T is continuous. What is a map which I will call F upper star of T? Should be a continuous function on X. And what is the obvious way that you will define it? You will define it by F upper star of T at X is equal to why is this continuous? F is continuous, T is continuous, therefore F star T is continuous. And now here, you think about what happens. So remember, the order is being reversed. F star is from C of Y to C of X. And what is actually going on here? What is actually going on is the following picture. What picture? So we have, suppose we have X to Y, and I have this function F is continuous. Yes. And now I'm taking a function T from Y to R. Then what am I doing? I'm just taking the composition here. This is just the composition. Yes? Now what happens if we have now, so F star is a composition. So what happens if we have a function G from Y to Z? So the picture I have now is X to Y to Z. X to Y is F, Y to Z is G. The composition is G composed with F. Okay? What is this G composed with F star? So I will have continuous functions on Z to continuous functions on Y to continuous functions on X. Continuous functions from Z to continuous functions from Y, I'll have G star. And continuous functions from Y to continuous functions to X, I'll have F star. And this composition that I have here is F star composed with G star. And what does this F star composed with G star do? It just says you take T of what? G composed with F at X. So I just want to write this down once. So So, what is it that we are doing? Okay, F star composed with G star at T. Where is T? Now T is in C of Z. T is in C of Z. So we have X this is T, and Y to Z we have G, and X to Y we have F. And all that we are doing here, G composed with F star, is just the composition. And what is G composed with F at X? It is F star of T at Gx. Okay, G composed with F star, its F star should go from C of Y to C of X. G of X is in Y, so T of G of X makes sense, and F star of this function, okay, is T of F of X. So just take some time to think about this. This is something very natural. All that it is taking compositions of functions. And the picture we have is this picture. So we have X to Y, and here we have to Z, and we're taking a composition like this. Okay? The point is that if you have a function in C of X, then how do you get a function on C of Y? So now if I have a function from X to R, for example, can I construct a function from Y to R? And this construction also you're going to come across a bit later on, where you have a map from here to here, and you have a map from here to here, and the question is, can you get a map from here to here? So if I'm given this F here and a T there, can I construct this map? And you will understand that in general you cannot construct this map, but in some special cases you can. And you have to find out under which special cases can you, if you're given this map from X to Y and a map from X to R, can you get a map from here to here? So this is a statement of lifting the function F to a function, something here, F tilde, from Y to R. This you will come across a bit later on. Right now we will not be worried about this. And obviously in general you cannot do this. And then you can do it sometime.